Hey guys, welcome back to another episode of Digital Days. Today we are live with Mad Science. Here's Professor Axion from Mad Science to wish you a happy back to school.
Happy back to school! Woo!
So what are we going to be learning about today?
We're going to talk about a really cool science called geology. And I think you're going to like it. Even though stuff seems to take a long time, like thousands of years, it's still very interesting. For example, we live in California, right? And this area, even though Roseville doesn't so much, but we do get earthquakes. And the reason, here we go, is, well, wait, hang on. Let's start at the beginning. Let's start with our planet. See our Earth? Now we have this thing all the way around us called a crust. And our crust is 22 miles thick. Kind of heavy. A lot of weight going on here. So all that weight makes the rest of this really hot. So in here in the mantle, we have a whole lot of magma, which is molten rock going all the way through everything. And then all the way at the bottom, we've got, middle, we have our core, which is iron and a whole bunch of other minerals and stuff. Very tough. So we've got all this, but our crust isn't like candy. It's not a perfect coating. It's cracked so that things can move. Our Earth is always moving and growing and doing stuff. And that's one of the reasons why we have earthquakes. So I've got a little sample here. We've got our, this is basically the crust. And if there's a lot of pressures, things are moving around and they're just pressed up against each other, it stays there, but sometimes it pushes so much, you get part of it up. Or, even more, part of it, big earthquake right there. Part of it down. And those are the things, those sudden shifts, that's what makes us move and have an earthquake. Also, sometimes, this isn't so much a California thing, but it's very much an Alaska thing. The Earth does this. And that is a weird earthquake, kind of like a wave and stuff. And it's just the Earth resettling itself. So one of the projects I did was I made a seismograph. Right here, out of a box. I have my cup. So what I did was I put some holes here. And by the way, you can find the instructions on how to do this on our website. Some holes here, holes in my cup. I have my pen. Take the lid off. I've got a little bit of Play-Doh here. You can also use clay. And put it in your cup so that it kind of sticks out like that. And then on top of that, to keep it settled, I'm not on camera. There we go. I'm going to pour some popcorn. You can also pour rice or rocks or just something to kind of hold your pen steady. Do that about halfway. It's nice and heavy now. It's going to hang. And I've got a slit in my box down here. Oops, there we go. Down here. And when I move my paper and I shake my box, I start to get a line. It's easier if you have two people doing this. And basically, I'm recording the movement. So that's how a seismograph works when it's measuring the movement of the Earth. But if you make one yourself, you can test the vibrations of anything. You can take your phone and put it on vibrate and put it on top and pull the paper and it'll show you just how much your phone is vibrating. Or you could put a toy on top that's moving around and you can see how it goes. You just have to slowly move your paper. If it's vibrating a little, you get little bitty marks, itty bitty marks, and it's moving a lot, you get huge marks like that. And it's kind of fun. Now, it looked awkward because, again, I'm all by myself, and it's easier with two people, or you can do it with a much bigger box, and that way it's not quite so delicate. But that's our size. There we go. That's our seismograph. Pretty cool.
That's awesome. So basically, that's what we use to measure earthquakes. Like, where are those? Are they down under the ground, or how do they do that?
They are on top of the ground, and they. Okay. Oops, I just spilled a lot of popcorn. I'll move this over here.
No one ever said science wasn't messy.
So I'll move all this aside. So no, they're on top of the ground. They're in all the places where there are faults. When you have a place in the core that moves a lot, we call that a fault. And they have seismographs all over around there taking measurements. And that way they can tell, looks like a lot of stuff is going to start moving pretty soon. We might have an earthquake coming up, or, oh, everything just settles down. We're not going to have an earthquake for a little while. It's really fun. Very interesting. Now, one of the things for the pressure also are when you get a volcano, and that comes up. But you know what? We're not going to do the volcano first, because that's a good ender with it. We're going to talk, first of all, about stalactites. So when, let's see, I get so excited. When you have a cave, when things have moved and an opening has happened underground, then water still is seeping in and leaving, and as water comes in, it brings minerals, and it leaves the minerals behind, and it keeps going. It's the same concept as when you get a geode. So here, let me show you that. And you see we've got all those pretty sparkles in there. That, yeah, so pretty. That was happening, again, because the water came in, deposited the minerals, and the water kept going. And this is a buildup of all the minerals that it was bringing up. Same thing for stalactites and stalagmites. Okay, stalactites are the ones that come down. Stalagmites go up, and sometimes they meet in the middle when they've been there for a very long time. And you can remember it. Stalactites has a C, stalactites, and stalagmites has a G for ground. C for ceiling, G for ground. And that's how you tell the difference. So I think we have somebody on your end who's going to help us with this next experiment. Is Sophie around?
We do. I have a little helper hiding behind me here.
Hello. Hi, Sophie. Okay. So she's got all her stuff all ready. You need a couple of glasses together. Yes, hers are much taller than mine, and I think that that's actually going to work better, the taller glasses, because my other glasses were small, and you'll see when I show you at the end. So you have 2 glasses, and you're going to want 5 spoonfuls of baking soda. Where's my baking soda? Here's my baking soda.
Do you need to borrow some? We can pass them through too.
That would be great. Just hand it right over. You want 5 spoonfuls of baking soda in each glass. Okay, so go ahead, take care of that. And you put them in. I'm just going to kind of cheat a little bit so that I can just keep talking while she's preparing. There you go. And what's interesting too, now it works better, it dissolves better if you have really warm water. So if anybody's doing this at home, I suggest you have an adult nearby so you don't get burned. You can use really hot water out of the tap, or if you have an adult, maybe use boiling water. Can you hear me okay?
Yes, I'm going to go help her and get some warm water for her while she
okay. Good, all right. So Sophie, while she goes and gets warm water, do you have any questions?
How does this work?
How does it work? Very good question. So here, I'll show you how mine ended up. I have corn kernels everywhere. All right. This is how mine ended up Now I should have more crystals in this middle bit. I think, can you see very well? Can you see how bumpy it is?
Yeah.
Okay, and if you look at my cup though, my cup actually is the better experiment. The way it all formed on the outside was kind of a surprise. We would wake up one morning and there'd be a whole bunch of it that had spilled down here on my plate. And we don't know how it got there. It just did. And then other days that would be dry and we'd just have a ton of crystals up here. Hang on, let's see if I can get this out. There we go. There we go. Okay, really, really, really close and show you.
That's super cool.
It is actually, and I think with your taller glass, you're going to get bigger crystals. So what you're going to do is you're going to put all that baking soda in your cups. Yeah, keep going. Then we're going to add super warm water to it, and that's to help it dissolve. Because I got to tell you, it's hard to dissolve it. Even though it absorbs water, baking soda is hydrophilic. That's why people can use it to deodorize things, because it grabs moisture and it'll grab odors right out of the air. So it likes water, but it doesn't like to dissolve. Also, when you add your water and you start stirring it, it'll fizz a little bit. And that's always fun. Where's my cup? There we go.
It's pretty warm water.
Excellent. Go ahead, and you want about 3/4 of a cup. So you're going to want to put about you've got a measurement thing. Okay, yeah, about 3/4 of a cup of water there. And if it's not exact, okay. I'm going to do mine over here. There we go. Are you getting any fizz?
Yeah.
Yes. Yeah, you get fizz if your water's hot enough. And then you stir, 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 stir. And it takes a lot of stirring. And you're trying to get it to dissolve as much as possible. There you go. And go ahead and keep that up. You may have to go back to it and stir it a little bit. Oh, and you know what? Do you have any food coloring with you?
Yes.
Great. Throw in a drop or two of food coloring in each cup. There we go. Bloop. The one I used on mine is a neon green, and it ended up all yellow and green and a little bit of blue. I kind of got a separation of colors, which was fun. Okay. Oh, I got a swirl. Yeah, that's because the food coloring is heavier than the water, but with the extra baking soda, it's not quite as heavy as that. So it's kind of like dissolving really cool. I love stuff like this. There we go. And then you just stir it and it becomes blue. Or what color are you using? Ooh, neat, 2 different colors. I love it. Okay, so let's pretend you stirred and stirred and stirred. You might have to stir it some more after we talk. And then you take 3 strings. Yeah, see how it keeps, gathering up at the bottom. Oh. Then you can take your 3 strings and you kind of twist them together to make one big string, kind of thick. Nice. Now you're going to take your string and you're going to go ahead and twist it up a little bit there first. And what we're going to do is we're going to put it in and get it started. And then we're going to stretch it between the 2 cups. And the water is going to work its way into the string, and it's going to keep doing that. The string is going to keep sucking water up out of those cups into the middle. Have you got it? Okay, take your string and pick one of your sides and go ahead and get it started. Just dip it in like that. Nice. You want to get the whole thing wet. So is the whole string wet?
Yep.
Yep. Okay. And then you're going to want to take it and you're going to put it in both cups and you're going to stretch it out a little bit further. Yes. Now, if you put a little plate in between them, you'll catch some of the water that drips down and you'll get the beginning of a stalagmite coming up. But I got to tell you, that won't be very big. All right. So you've got that across. Now what's going to happen is through osmosis, that string is going to keep sucking up all your water and bringing it up into the middle. And as it brings it up, it's going to bring that baking soda every single time. And it's going to deposit it in the middle. And then the water is going to evaporate, but the baking soda crystals will stay. And it's going to take about 5 days. You're going to want to put this someplace where it's not going to get knocked or anything, but it's going to take about 5 days. Mine's about 4 days old because we accidentally knocked mine over on the second day, so the first time, so I had to restart. But let's see, where is it? There we go. There's my camera. After about 5 days, you should have even more than this.
Huh.
Yes. And if 5 days seems like a long time, I'll just remind you that a proper stalactite usually takes 500,000 years. So I think 5 days is pretty quick. Now, Sophia, seriously, once you've got it done, I want you to take a picture of it and send it to us, please. Because we love it when people send us pictures of them doing science. If you send it here, here's our email, is online at sacmadscience.com. If you send it to us, we love it. We will not post it without your permission. If you want us to post it, just tell us and we'll post it everywhere. But we love seeing people like you doing science. Love it. So do we still have a little bit of time? Do we have enough time to do a volcano?
Absolutely. We always have time to make volcanoes.
Excellent. So I'm going to move my stalactites over to one side. Now, does anybody have any questions so far about stalactites or seismographs? No? Okay. Then come over here. Now I'm going to make 2 volcanoes. Oh, remember I said volcanoes happen when we need to relieve pressure in our crust again. I've got a little thing here to show you.
I'm going to make it a little bigger now.
Okay.
Oh,
Sophia. So here we've got our magma, and it's building up and building up and building up. And then finally, what happens is a lot of gas gets into that magma, and it starts to raise, and it's just got to go somewhere. So if there's a weak spot in the crust, it comes through. And there are some that just shoot out all over the place, some volcanoes. There are some that just kind of ooze up and go. And then there are some that just slowly build for thousands of years. That's how we get some of our island chains. But anyway, yeah, let's do some volcanoes, shall we? So first off, I'm going to take a little baking soda, and I'm taking a piece of paper here and using it as a funnel. And I'll put that in there. Now this is an Erlenmeyer flask, and it makes an excellent volcano. There we go, put a little bit in here. I would put about 2 spoonfuls of baking soda. That's probably the best. This is stuck. Here we go. There we go. And I'm also realizing that hardly anybody has a flask at home. I'm going to make one in a teeny tiny bottle too, and we'll see what happens. So I'm going to roll that up, make that even smaller for my teeny tiny bottle. There we go. put that in. Oops. And we're gonna, ooh, that one has a ton. That's a lot. Okay, let's find out what happens. So the best way to make an excellent volcano is you're going to take a little bit of dish soap, and that makes your lava ooze. And you like oozy lava, it looks awesome. So I'm going to put some dish soap in that one, and I'm going to put some dish soap in here for my little volcano. Okay, this, by the way, is a graduated cylinder. It's a piece of equipment that is awesome, one of my favorite lab equipments. Okay, next step is we get the vinegar and we add that to our soap. So we're going to put about 50, maybe 55 milliliters in here. Now the reason I added my soap first is so that it would mix in to my vinegar and I didn't have to stir it too much. And then I will put some in my teeny tiny cup for my little one. There we go. And as you may know, lava is a color. So I'm going to make my big one pink or purple. I think this is purple actually. It's usually red, just saying. Okay, 2 drops of food coloring into there. And I'll make my little bitty one, I think we'll make that one green. And so, loop, loop. All right, so I'm now going to lift this up so that you guys can see what's happening. I need to move aside all my rocks and the spilled popcorn. There we go. Oh, still can't see it very well, so I guess I'll hold it. Okay. In that case, I'm going to move the little one out of our way. Here's our big one. So again, that's baking soda, a little bit of dishwashing liquid, vinegar, and a little bit of food coloring. And keep an eye on it. And you want to pour fast and get out of the way. Nice. And the thing is, you can never really tell if it's going to come out all the way, all over the sides, or just one place. Oh, it's very pretty. Hang on. I think purple lava is awesome. There you go. Now, when we did it here in this flask, that gave us lots of room down here for it to start and then work its way out, right? So you're going to see that my little bottle is going to be a little bit different. I'm going to put this down over here. Please don't spill. I'm going to bring my little stuff over here. Okay, are you ready? And boom, just all at once, just all over the place. And that's because it comes straight up and out. And again, I did that because hardly anybody has a flask around. And I'm just showing you, you can do volcanoes using all kinds of different stuff. This is a bottle, a tiny bottle. You can use big bottles. Talk to your parents. Plastic bottles are awesome. If you want to put them in something with a lid, do not put the lid on because that is dangerous. All that pressure will build up and break your bottle. Does anybody have any questions?
That's super cool.
I know. I know. It's so awesome. So yeah, those are the kinds of experiments you can do in geology. And also, geology is so cool because of the rocks. And California is one of the best places, one of the best states for rocks because we have so many different ones. Now, I said that. I don't know if my rocks came from California. I'm just going to show you some really cool rocks. So this one, huge bunch of crystals all together. Just gorgeous. And I have another geode here, which it's not as sparkly in this light. It's really sparkly to me. let's see. Oh, and I have 3 lava rocks. These are the ones that got hard really fast, and they've got lots of holes in them. And they're kind of like, I've known people who drew on their sidewalks with them and stuff. They fall apart very easily. And here's a great big chunk of quartz. And let's see. Another one here. This one has a bunch of little tiny crystals in it that are very sparkly. I think that this might be an igneous rock or a sedimentary rock. Not sure. I would have to double check that. Oh, and then this, very hard. You can see layers in it. So cool. And there's all kinds of information you can get from the rocks. So seriously, there are rocks everywhere. You can study them so easily. Get yourself a magnifying glass and take a close look.
Awesome. My favorite ones that are the painted ones.
The painted ones?
Painted ones. Your rocks.
I love it. I love it. So,
awesome.
Everybody have a wonderful school year. Okay, it's all very exciting. I know it's weird this year, but it's also very exciting. So enjoy yourselves.
Well, thank you, Professor Axion. We appreciate all of the science magic you showed us today.
Oh, of course, and thank you for letting me talk to you because I love it.
Absolutely.
Thank you for introducing me to Sophie. And in all seriousness, we want to see a picture in 5 days of what happens with her stalactites. All
right, we'll do.
Okay.
Make sure that you guys tag the School District Foundation too for your stuff that you post, and we look forward to seeing your creations.
All right. Thank you. Hi, Sophie.
All right. Thanks, guys. We'll see you next time.
Bye.